On April 1, 2026, this luxury cruise ship departs from Ushuaia, Argentina. On board are 150 passengers and crew from 23 different countries, setting off for a scenic voyage across Antarctica and the South Atlantic. 5 days into the trip, a 70-year-old Dutch passenger visits the ship's doctor, complaining of a sudden fever, headache, and mild diarrhea. Within 48 hours, he is struggling to breathe. His condition deteriorates so rapidly that by April 11th, he is dead. When the ship docks near Africa a few weeks later, the victim's wife disembarks with his body to fly back to Amsterdam. She never makes it. As she is about to board her connecting flight in South Africa, she suddenly collapses in the airport and dies the next day. Back out on the water, the crisis multiplies. A German woman falls seriously ill and dies within 4 days. One by one, healthy passengers trapped miles from any shore are coming down with the exact same lethal symptoms. By early May, the World Health Organization receives the official diagnosis, Hantavirus. It is an illness with absolutely no vaccine, no proven antiviral cure, and a staggering mortality rate that can kill up to 50% of the people it infects. But the diagnosis contradicts decades of medical science. Hantavirus is widely known to spread exclusively from infected rats to humans. There are no rat infestations in the pristine passenger cabins, yet the infection is tearing through a sealed ship from person to person. To understand what is happening on that ship, we have to look at these soldiers fighting in the 1950s Korean War. In the middle of the conflict, more than 3,000 American soldiers were suddenly struck down by a bizarre illness, causing extreme fevers and kidney failure. 15% of them died, and doctors initially suspected a chemical weapon. 30 years later, a South Korean virologist finally traced the infections back to the source: rats living along the banks of the Hantan River. He named the pathogen Hantavirus. This diagram illustrates how the virus attacks the body in 2 distinct ways. In Asia and Europe, it manifests as HFRS, where internal bleeding occurs and the kidney shut down. But in the Americas, it causes HPS. The lungs fill with fluid, making it impossible to absorb oxygen until the patient suffocates. In the spring of 1993, the American variant struck the Navajo Nation. Young, perfectly healthy people were suddenly drowning in their own lung fluid. The mortality rate hit 75%, and scientists were completely baffled, until tribal elders pointed to the weather. The elders remembered that during heavy rains, the local pine trees produced a massive surplus of nuts. That massive food supply caused the local rat population to explode. More rats meant more contaminated droppings, drastically increasing the chances a human would sweep up a dusty room and inhale the virus. The data revealed a direct link to the massive 1991 El Niño weather system. A major environmental shift caused extreme rainfall, which fueled a booming rat population, which ultimately forced the virus into human living spaces. The rule that hantavirus only jumps from animals to humans held absolute until an outbreak in southern Argentina in 1996. Scientists identified a terrifying new mutation called the Andes strain, the only known variant of hantavirus capable of spreading directly from one human to another. This exact Andes strain is what boarded our 2026 luxury cruise. Right before the ship departed, the older Dutch couple, our very first victims, took a birdwatching excursion in Argentina. Their tour walked them directly through a local landfill heavily infested with rats. This timeline illustrates a crucial biological bottleneck. While the Andes strain can transmit between humans, it is surprisingly terrible at it. An infected person only has a tiny window of just a single day early in their sickness where they are actually contagious to others. Now look at what happens when we laid the Dutch couple's travel schedule over that exact window. If they had waited 2 or 3 days to board the ship, they wouldn't have been contagious anymore. Instead, they boarded immediately, carrying the active virus directly into the crowded, enclosed environment of the cruise ship at the exact moment they were shutting it. A rare, localized viral strain met an astronomically unlucky travel schedule, turning a single birdwatching tour into a maritime crisis. By May 10th, the crisis on the water was contained. The ship successfully docked in the Canary Islands, the infected passengers were medically evacuated to specialized hospitals, and a strict quarantine locked the virus down. But because we know human-to-human transmission is biologically possible with the Andes strain, the obvious question remains: Is the world facing the next global pandemic? The answer is no. Unlike COVID or the flu, hantavirus is not airborne. It requires prolonged, intimate physical contact, like sharing a bed or directly caring for a heavily infected patient, to spread. If you isolate an infected person for just 2 days, the transmission chain completely breaks. This map shows sea surface temperature anomalies, with the dark red areas indicating severe El Niño conditions. That is the real immediate threat. We're entering another major El Niño cycle, meaning extreme rainfall, intense vegetation blooms, and an inevitable massive explosion in the global rat population. You cannot vaccinate against hantavirus, so you have to block its entry into your life. That means physically sealing any small gaps around your home so rodents cannot enter. It means strict trash hygiene, so you aren't leaving food sources out. And if you have to clean out a dusty, enclosed space like a storage shed or a barn, wear an N95 mask and gloves. With a 50% mortality rate, hantavirus remains one of nature's most lethal biological threats. Defending against it requires no pharmaceutical breakthroughs or lockdowns, only consistent pest awareness